Hey friends, welcome again to another session on polynomials. And in this session, we are going to discuss a very vital concept, and that is called zero of a polynomial. Zero of a polynomial. So, polynomial, we have already defined in the previous sections. So, if a polynomial px is given as a n x to the power n plus a n minus 1 x to the power n minus 1 and so on and so forth till, let's say, a1x plus a0, where a0, a1 and an all were real numbers and n not equal to 0. Okay, n was not equal to 0 and n was a non-negative integer. So we are only dealing with such kind of algebraic expressions which are called polynomials. Now, in this session, we are going to understand the concept called zero of a polynomial. So, whenever there is a polynomial given to you, can you find out what a zero of a polynomial is? Now, let us first define a zero. So, what is a zero of a polynomial? So, as the name suggests, a zero of a polynomial is those, or it actually should be are those values of x for which px, the polynomial itself, becomes a zero, right? So if you see here, this is the value of the, and we learned how to find out value of a polynomial. So if you somehow find a value of x such that if I deploy that value of x in the entire expression, this expression must reduce to 0. So we are interested in a particular point or in a particular value of x which is making px as 0. Now you might ask, why is this necessary? So later on, when we'll see solving equations and factorization of a polynomial, then how zero of a polynomial becomes very critical. Now let us take a few examples and understand. So you would have studied linear polynomials, and here is an example of a linear polynomial px which is given as 3x minus 2. Linear, why? Because the degree here is 1, hence it's called linear, and we have already shown and we have already discussed that the graphical representation of such a polynomial is a line, and hence we call it a linear polynomial. So if you notice, if I put x equals to 2 by 3 in this expression, x equals to 2 by 3 in this expression, what do I get? I get px equals 0. So if you see, at x equals to 2 by 3, this particular polynomial is going to be reduced to 0. So hence we call x equals to 2 by 3 as the zero of a polynomial px. Okay, so hence what did we find? We find there is one zero. Again, there is significance of this, we will study a little later, but please bear in mind that a linear equation, or sorry, not equation, a linear polynomial can have one zero, right? Can have one zero. Now let us take another example. Now in this example, we have taken a quadratic polynomial. Why is it quadratic? Because the power here is 2, so the degree is 2, so hence this is a quadratic polynomial in x. And now if you see, what values of x are going to reduce px to 0? So if you see, if I put x equals to 1, then what does this polynomial become? So p1 is equal to 1 square minus 3 times 1 plus 2, hence it is coming out to be 0, right? Similarly, if I put x equals to 2, I get 2 square minus 3 times 2 plus 2, which is again 0. So hence what do we see? We see that if you put x equals to 1 or you put x equals to 2, in both the cases, the quadratic polynomial x square minus 3x plus 2 gets reduced to 0. Hence we say there are two zeros of this polynomial. Now let us understand how it looks, or how the graphical manifestation of these polynomials look like. Before that, please note that a linear expression can have, or linear polynomial can have, one zero. We will see it, why it is happening like that. A quadratic can have two zeros, but it doesn't mean that for every polynomial you will get a value of x such that the polynomial gets reduced to 0. Example, let us say if you had px is equal to x square plus 2x plus 3. Let us say you had this quadratic polynomial. Now there is no real x, there is no real value of x, no real x, which when put in this expression you will get this as 0. There is no value of x. You can see the proof later on, and if you really see, it is nothing but x square plus 2x plus 1 plus 2, isn't it, which is nothing but x plus 1 whole square plus 2. Now this quantity can never be 0. Why? Because this quantity is a square, so square term, the last possible, the minimum possible value of a square is 0. It cannot be negative ever, so minimum possible is 0, and then you are adding 2 onto it, so hence you can never expect this particular expression value going to be 0 for any real value, however much small, big, but whichever number you put here as x, since 2 is getting added, so by inherent nature of this polynomial, this is never going to be reduced to 0, right? So it's not necessary that you will get 2 zeros always for a quadratic polynomial. Also there is no possibility of getting 3 zeros. So always remember, number of zeros of a polynomial of degree, let us say n, is always less than equal to n. Okay, so number of zeros of a polynomial of degree n will always be less than or equal to n. So if you have a polynomial of degree 5, then number of zeros will always be either 5 or 4 or 3 or 2 or 1, like that. And we are talking about real zeros, right? So we'll see. Now there would be you'll be seeing cases where if there are if we'll see in different cases where, let's say, the degree is even and odd, then the possibility of existence of real zeros will be in pairs and other such features in subsequent sessions. Okay, so what I mean to say is, if n is odd, it will definitely have either one real or 3 real or 5 real roots. 1 real, 3 real or 5, and likewise we will see different cases. Okay, so let's not go there in right now, because we need to understand the concept of zeros, and for that I'm going to show you the visual representation of polynomials and how exactly, on where exactly you can find 0, or what is the physical significance of 0 of a polynomial. So welcome folks, this is a GeoGebra tool. So we are going to see, first of all, let us say I have already done a graph for you. So I have taken a graph, and this is fy is equal to 2x minus 3, f of y, so sorry, f of x. If you see this particular graph, this is nothing but y is equal to 2x minus 3, or f of x is 2x minus 3. Now if you notice, there is one point where the graph is intersecting the x-axis. Okay, here is where the polynomial, or the value of y is equal to 2x minus 3 is becoming 0. And what is that value of x? You can see it is here, 1.5 comma 0. So hence x equals to 1.5 is the 0 of this linear polynomial. And if you can see, this polynomial, this graph is cutting the x-axis only 1, and no more, no less. Now let us go to quadratic polynomial and see what does it look like. So this is another quadratic polynomial, if you see. Okay, quadratic polynomial. So hence, if you see, as x is increasing from, let's say, left hand side, from negative infinity side, the value of y is decreasing. If you notice, the y values are going decreased like that. It is decreasing, and finally here it is becoming 0, isn't it? And then it is going further down, and then starts increasing again hits 0, and then it keeps on increasing, isn't it? So here, what is it? This is nothing but, this is, if you see, there are two zeros, there are two values of x where the polynomial is becoming 0. And what are those values? So the values are this and this, right? So if you see, this value is x equals to 1 and this value is x equals to 2, if you notice, right? So at these two values, the value of the polynomial, quadratic polynomial, is becoming 0. Now let us once again check another polynomial of degree 3, and this is another polynomial of degree 3. So let us say the polynomial is x cube minus x square minus 3x plus 1. And again, if you see, there are 3 points where the curve is becoming 0, or the value of the polynomial is becoming 0. So this D point is there, which is minus 1.48. This point is 0.31, and F is 2.17, right? So there are 3x where the cubic expression or polynomial is becoming 0. Now, as I told you, this is not necessary that every time you will get 3 zeros only. So you will see, when we'll be dealing with the graphs of the polynomial in subsequent sessions, you will see that there is a possibility of at max 3 polynomials, not three possible zeros are there, not more than 3 for a cubic, right? So it can also have 2, or it can have in fact it cannot have 2. We'll see how odd number degree of a polynomial behaves. So it will have either 1 or 3 real roots. And if it is having one unreal root, that is called a complex root, then it will have minimum of a pair of a complex root. So all of that we will be seeing when we'll be dealing with, let's say, graphs of like polynomials. Right now you understand that maximum number of zeros of any polynomial of degree n is n. Okay, so this is a demonstration of what zeros of a polynomial mean and how they are represented on a graph.